One, two.
It's going to be Arnold on yourself and then Rich. All right, guys, we might make a start here. So good afternoon, and thank you for for being keen to attend this session here. We've got a what I believe is going to be a very interesting panel discussion on security from an SDN perspective. So as you know, for the past 5 or 6 years, the industry has been working hard at implementing SDN solutions. We've seen a lot of work in the standards area within the open source community with operators as they've deployed solutions around SDN in the data center, SDN in the WAN environments, and SD-WAN kind of solutions. So what we'd like to do today is have a look at this from a security perspective, right? What are some of the key concerns, how we as an industry are dealing with them. So I've got a very distinguished panel, and it's a nice sort of cross-section across service providers and the vendor community. So we'll be getting a very, or what I hope is a very balanced view of security. So let me start and introduce the panelists. So on my left there, to your right, we've got Jeff Young. He's from Telstra, and he's got a very extensive resume. But let's just say that at the moment he works on a very significant SDN implementation at Telstra. So he'll be talking a little bit about that. Next to him, we've got Arnold Nipper, and Arnold is from DKIX, and they operate a very large, well, probably the largest IX in Europe, and so he'll be providing us a perspective of securing the infrastructure for the users. We have Margarita Correa, who's from Juniper, and she's been involved in all aspects of security to do with the cloud environment. So we'll be hearing from her on that. And last but not the least, we've got Rich Bayless, who's working with Arista. He's already delivered a few presentations today, or to date, I should say. And once again, he'll be providing a vendor perspective on securing SDN. And he's got a very interesting analogy that I hope you stick around for. You'll find it quite amusing at the same time as interesting. So the way we're going to work this is we'll give each of the panelists a few minutes to present an aspect of SDN security related to the environment that they should work in. And at the end of it, I'll open up the floor for the audience for any questions that you might have regarding their presentations or SDN security in general. So with that, please join me in welcoming the panel. And we'll ask Arnold to come up, or maybe just stay there. It's up to you for his presentation.
Yes, thank you very much, Paresh. Yeah, I'm Arnold Nipper from DKIX, and I will talk a little bit about SDN or SecureSDN from an IX point of view. And this is not so much from, especially from a DKIX point of view, but I guess as far as I know, it's more from our industry, from the IXP industry point of view. So, and I need the clicker. So first, let me recap what an internet exchange point is. Basically, it's just a network facility which enables the interconnection of more than two independent autonomous systems. So basically, this is not, or unless an ISP, this happens on layer T most frequently. And so technically, what we know is currently we have roughly 650 IXP worldwide, and most of these internet exchanges, these are small to medium-sized internet exchanges, which simply run a single switch, or let's say two switches, mostly also in layer 2 technology, and which is not really a rocket science. The bigger ones, they operate in a loop-free edge core topology. That means you have a set of switches which are edges where you connect the customer to, and all these edges are connected then to a core. And since roughly, I would say, 10 years, the really big ones, they run VPLS, MPLS in their core network to be able to load balance and to cope with the traffic. And only a few IXPs use SDN, and this is more the really small one. I know about IXPs in New Zealand, which run on SDN, and I also know a small IXP in France, in Toulouse, which run on SDN, and this basically was also the end result of a PhD network. There has been quite a bit of research in the SDN at IXPs. There has been EU project research where also our company participated in, and they just finalized, and we will later see what the result of these findings are. So what are the typical use cases for perhaps SDN at an IXP? So there are 2 points of view. First, the operated use cases, and then, of course, the participant or member use cases. For the operator use cases in terms of security, safety, you want, or you may use SDN for access control. So what you want to make sure is that every participant, or you can say an IXP, more or less is a big LAN party. And you have to make sure that every participant who connects to this LAN only comes with his MAC address, only with certain protocols, in general IPv4, ARP and IPv6 and nothing else. And if he changes MAC address, you have to be aware of it, and so on and so on. And the next thing is broadcast prevention. You have to make sure, or you have to be aware that, especially at large exchanges, you find participants which connect with just 100 megabit, and the largest one with multiple of 100 gigabits. And what you have to make sure is that the large ones do not overrun the smaller one with broadcast. That means you have to take care of broadcast storms, broadcast limitations, multicast, and so on and so on. And there is also, this is a use case where SDN also may prove viable to do that. In most cases, it is that you simply get rid of any ARP protocol and simply use a mechanism to provide next hop reachable information. From the other point of view is for the participant use cases, what participants might be look into is advanced black holing. I will go into detail that in the next slides, and control plane traffic protection. It's the same as with broadcast prevention. You have to make sure that your participants are not overrun by control plane traffic. So this is how currently at a few or some IXPs, how traditional filtering at IXPs is done. Simply all traffic is dropped for a certain address, and you are not able to distinguish any protocols. That means what a customer or a network at an IXP does, mostly via the route service, it announces a /32 or a /128 when it's an IPv6, and then traffic for this IP address is dropped ingress in the infrastructure. And with SDN, you would be able to do more fine-grained black holing, or even, I would not even call it black holing, but some sort of DDoS mitigation even. You would be able, for example, to drop UDP traffic, to rate limit, and not only to throw away the whole traffic. Yeah, and that's from my side. So all in all, SDN is not yet an issue for IXPs. The reason for it, for the smaller ones, they are often run by voluntaries. After hours, they simply don't have the time to look into this. And for the bigger ones, we also still have scaling issues because the bigger ones, like, for example, AM6 links or DKIX, they run switches with a lot of ports, and it's hard to find hardware which both supports SDN and the amount of ports what we need. Thank you.
Thank you very much, Arnold. Before we go into the next speaker, does anyone have any questions specifically for Arnold based on his presentation? So maybe I might ask one, Arnold. From a user security perspective, have you seen a measurable improvement from pre-SDN to now your SDN environment?
From pre-SDN?
Yeah, so prior to having SDN, you had obviously some mechanisms in place to provide security, and now you're using SDN mechanisms to better secure your network. Is there some measurements or measurable data that would indicate that you've benefited from this?
As said, perhaps I was not clear enough on this. DKIX at least is not yet using SDN. If we will use SDN, then we definitely will only do that if we see an improvement. And the big improvement we see in the use cases I mentioned, especially internally and also especially for the customers.
Kiriti Kompella. So there are some IXs in Europe that are using root servers for doing the BGP connections between the customers. So in principle, the BGP customer should have a direct eBGP session, but they go via the root server.
So it's up to the customers what they want to do. Either they have bidirectional sessions, or they may also go via the route server.
So if they go via the root server, would you consider the root server as a kind of SDN?
In some sort it is, yes.
Yeah. So, but DKIX is not offering that?
Yeah, DKIX is offering root service since the very beginning, and you are right, in some sort it is, especially because the newer root servers, what they do, they drop their ASN in between, they
make sure things are sane.
MEDs, they work on everything, so they are not standard BGP speakers anymore.
Thank you very much, Arnold. All right, we shall move on to the next speaker, Margarita. Thank you.
Okay. It's working. Thank you very much. I'm going to talk about SecureSDN from the point of view of what we've been getting as requirements from our enterprise customers, what we're seeing as the trends, and then how we are trying to address the security needs from customers to use SDN and cloud solutions for their IT needs. So the trend number one with enterprise is adopting the cloud in some way or form. We've seen some customers first going for a SaaS approach, using, for example, Office 365 or the workplace. But we also have seen customers wanting to use cloud, use public cloud, and use an extension of their on-prem data centers, extending it to the public cloud on a hybrid cloud way. So some customers have their own application developments, and in that case, they want to go and use microservices. They want to develop their applications to use the new way of PaaS environments with containers. And in this case, the network has to be extended from their current setup to also extend it to the cloud. When you have production services that run inside the customer data center and also public cloud, you need to extend the network policies, network reachability and security across this heterogeneous setup. Now, the situation is that most of the networks at the moment don't have all the feature set to adopt the multi-cloud services. What we have is we have branches and enterprise campus, we have some data centers and security on the edge of those networks. Some people are trying a bit of cloud services. They usually have 1 or 2 connections, but not have everything ready to take it on production. And what the desired state is to have connections that are service aware and security that is application aware. So in a context base, you have security policies that allow or not allow applications to talk to other applications and for users to also access different applications in different environments. So what we are now creating solutions for is for customers to adopt a single SDN solution that provides not only the needed connectivity, but also security. That is to address that and to have that, you need to have both the underlay and the overlay visibility and to have and be able to understand how the network infrastructure can support the new type of network connectivity required for the multi-cloud applications. In terms of security, you need to have a way to configure security policies across all the networks and per application. So we are adopting a centralized system for policies that understand the context and the application environment. And as such, you can use the same policies across 4 applications, no matter if they are deploying on-prem or on the public clouds. One of the main requirements we have when customers move from trying cloud for just their development or use to go into production is encryption. So with the Contrail vRouters now, you can have encryption between the workloads, no matter if they reside on virtual machines in data centers or in public cloud, or even if you deploy a PaaS environment, like, for example, the Red Hat OpenShift. If you deploy it on a public cloud, and if you have Contrail as the SDN layer, you can have encryption tunnels between the public environment and the private environment, as well as having between vRouters within the public cloud. You can have also encryption between those. But security is not just encryption. We're looking also at these 3 different areas. The intent-driven policies, so that the policies are now defined in terms of what applications are and which users can connect to such applications. So no matter where you deploy your applications, you can reuse the same policies. On the second one, it's the multiple enforcement points. So we're no longer going for huge firewalls that have where you have single point of contention for all traffic to apply rules. What you have is each virtual router can do layer 3, layer 4 type of enforcement for security rules. And when you need layer 7, you can service chain virtual gateways such as the VSRX to apply those type of policies. And the third part that is also very important is the analysis of the traffic that is going across the network. And in this case, what we can provide is we can provide underlay and overlay correlation. And what you also can see is like which policies are being used, which traffic is going through such policies. In a bit more detail, for the intent-driven policy, what we are doing is that we are defining policies that are based on rules, and rules are based on tags. So no matter which IP address you used for a virtual machine or for a container, you can apply the same rules because you tag that type of container or virtual machine, and then you can use that tag to create the logic for the security rules. This is also true for users because you know at the moment when you log in into a network, let's say if you use Secure Active Directory or so, you have roles and those roles become tags that can be also used in this framework for policy definitions. You can have general policies, you can have more localized policies that can take in account a project or a namespace that can take in account also what you have in terms of geographical positioning of your applications, for example. The multiple enforcement points, as I said, the same policy can be applied across a distribution of vRouters on the SDN, can be used on virtual firewalls, but can also have the policy being pushed into physical firewalls through APIs. And this one is about the visualization that you can have in terms of analytics information on the SDN layer, in terms of which connections you have and which policies are being used by the traffic. So in the end, what we're trying to provide is a secure, automated, multi-cloud environment that no matter where users are coming from and no matter where applications are based, you can provide service-aware, like application-aware connectivity based on the network and security policies that have been defined or predefined on a per-application basis given the application needs and the policies associated with them by the security administration. That's it. Thank you.
Thank you very much. Once again, I'll invite questions from the audience.
So, Kiriti Kompella, you mentioned that for, even if you have end-to-end encryption, you still need other security mechanisms. Is the reason that for legacy applications, or because you would intuitively think that end-to-end encryption, you're done, everything is fine and secure, but what's the reason why you need more than that?
So one of the examples is that within an enterprise, you have applications that you allow freely to interconnect, and other applications you don't.
Okay.
There's also development environments, Q&A environments, and production environments that customers need to separate within their networks.
Okay, all right, thanks.
Right, thank you very much. So we'll move on to our next speaker, Jeff Young. So Jeff, thank you. Use this or?
Yeah. I'm tired. I'll walk around a little bit. Hi. So I'm going to switch gears a little bit and talk more about service provider and service provider infrastructure. So I've got a small network that, well, it's a global network, but it's small in number of switches and such. But I'm going to take us through what you have to think about when you're trying to secure that infrastructure, especially in an open flow network. So it's the Telstra programmable network. I'll talk about how I view the problem, some basic vulnerabilities, application vulnerabilities. There are some things that I didn't put in the slides that I'll talk about because I'd probably get flailed if I did put them in the slides. But we'll just get to them when we get to them. And then I've given you some of the research that I did on this and some of the research papers. So this is the TBN network. As you can see, it's all over the globe. It's about 35 POPs. Essentially, it's connected up to a GUI, and you can string connectivity 1 gig, 2 gig, 4 gig, 5 gig, Hong Kong, LA, New York, New York, London. You can run NFVs inside server farms in those sites. And so I could hook up a router, and have a network connecting my London site to my Hong Kong site, right? So that's the basics of the platform. There are other things that are on it. You can choose all kinds of different virtual machines and NFVs, but that's the gist of it. It runs on OpenFlow, and basically all it is every one of those flows is an Ethernet. So you hit an open flow switch, port and VLAN in, port and VLAN out, off you go, right? And so that's the basics of it. How do you protect that? If you look at what OpenFlow actually does, it's a sort of a turning networking on its head a bit. We're going to separate control and data planes, obviously. And so the switches don't do anything like modern routers do. They're very dumb. You know, packet comes in, I can identify packet, packet goes out. If I can't identify packet, I drop packet. That's basically the idea. There is a provision in OpenFlow where I don't drop packet, I send packet to controller. Then controller says, oh, I don't have a rule for that. Here's a rule, right? And that's one of the main problems in all of this, is security-wise, is that people can game that, right? The switches have a limited forwarding table. We use a protocol, well, we don't really. The spec says use this OpenFlow discovery protocol. It's essentially LLDP. And the controller will come and say, here's this LLDP packet, Mr. Switch, send it out all of your ports. And when controller hears it back, it knows that there's an inner switch link between these two, right? So there's a bit of gaming that can go on there. Network traffic, like I said, can prompt a controller to create a forwarding rule or create a drop rule or do something else, right? So you could, if you get traffic that you don't know what to do with, you could send it up there and controller will tell you what to do, right? So in that are all of the ways you could possibly, well, many of the ways you could possibly game this system, right? You could certainly attack the controller or the application, and that's certainly keeping your controller safe is security 101. Keeping your application safe is really application security. We'll talk a little bit about it, but not much. That's not really what I was here to talk about. So in a sense, the controller is the smart thing. It is the brain of the entire network, and the switches are just stupid. So people have come up with ways to overload that controller. I send it a whole bunch of packets it doesn't know what to do with. Suddenly it's got a whole bunch of things it has to think about and send back to all of its switches. Or I go switch by switch and I start figuring out what the switch has as a path. When it doesn't have a path, boom, yeah, I got one, and I start making the controller put that path in there. And suddenly I can get to the point where I can overload that switch table because it's a finite set of rules, right? A lot of focus for us, we don't have necessarily this problem because we don't allow that to happen. We don't forward packets that we don't know what to do with, we drop them, right? So don't have that problem. But if you're going to run a real OpenFlow network, you'd probably have to, well, we're a real OpenFlow network, but yeah, you'd have to deal with that. This is more of a problem for us. And how do we do switch discovery, right? So you got to do topology discovery, and topology is constantly changing. ISLs are going up, going down. We've got international bandwidth on here. We've got 10 gigs. We've got leased line. We've got fiber. We've got to constantly create that topology, and the topology is changing. So what happens if we have someone who's out there and is masquerading as a switch? He's perhaps grabbing those LLDP packets and doing something with them, or making them appear elsewhere in the network. Because if you made them appear elsewhere in the network, suddenly it looks like I got an ISL there, but I really don't. And then the controller has north and southbound APIs. The northbound API, this API is probably the one we're most concerned with, and attacks that would come in this way, or even come in to the application itself, are most worrisome for us. And then a network traffic might be able to even prompt a controller to create malicious rules. One of the things I didn't put in here, what about legal intercept, right? Many times you've got in a country the notion that I have to do legal intercept. Someone's got a court order, I have to take all the traffic and push it there. So there are ways in this network to grab all the traffic from a certain customer and send it somewhere. We don't talk about them, but right, we certainly don't want anyone to tweak them and use them for their own nefarious purposes. Solutions for us, certainly simple, yeah, simple, but perhaps hard to do, protect that application. One of the things we do in the application is anytime we've got any API call, any GUI action, we carry the token through every one of those calls, right? So we don't just authenticate you once, you tell us the token once. Every one of the actions that you take on our network, we carry that token and we validate it, right? So it makes it a little bit back and forth, back and forth, back and forth for us when we're actually doing something, but we can be sure that the token is valid each time you do an atomic operation on the network. Like I said, we don't forward the traffic to the controller and ask it what to do. We just drop it because it's the customer's flow. It shouldn't have anything that we don't know about. It shouldn't have a VLAN that we don't know about. Looking at some of the, and I had an earlier talk today about a controller that we've actually written. We don't necessarily use OFDP, LODP. We're doing something a little different. We're encrypting some payload, wrapping it in UDP, sending it, and allowing the controller to do its thing with that traffic. But we can be certain that that was sent by the controller itself when we get it back. The only problem we necessarily have is if customer connects to this switch and perhaps that switch and does something silly like makes those packets do this, go back and forth, then suddenly we get a little confused. But that's part of future controller development for us, which you're all welcome to participate in because it's an open source project. But the notion of only sending those packets on the ISLs themselves, right? So don't send them out this customer port, just send them on these ISLs is a future enhancement that we'll do on the Open Kilda platform. Like I said, there are ways that attackers might fingerprint your controller. You're running Open Daylight. They might be able, by pushing things in and out, to know that you're running Open Daylight. Now they can have a targeted attack on Open Daylight. And so one of the things that we've done is we've written our own controller. That was not the reason for it, wasn't security, but it'll take people a while to sort of get at the notion of how to fingerprint our controller. Yeah, so again, we've written a whole controller. I won't spend any time on that. That's there's an earlier presentation if you wanted to get at it, but that is the swim lanes for the our controller, right? And our controller is highly distributed, so we've got Kafka, we've got Hadoop, we've got stream processing on this controller. So we're actually doing things out in the network because we've got upwards of 300 milliseconds latency on this network. We're doing things and processing things outward. So it would take quite a distributed attack to get into that, I'm sure. But this controller goes live end of the month. No good plan survives contact with the enemy, so we'll see what happens, especially from a security posture. I'll skip that one. This is application security. So this is a view of our GUI, and each one of these things is either a virtual machine or a connection to a VPN network, or this is a flow between two sites. Right, so you could have this one in, I don't know, I can't read. Oh, that's in the UK, and this one's in Japan, right? So I could bring up bandwidth between the UK and Japan. Right. Obviously, this is worth protecting because that kind of bandwidth, a gig between those two sites is pretty expensive. It's also worth protecting our customers' data, so it's worth doing. If you want to see what the portal actually looks like, I put that in there. I won't go too much into it, but that's the kind of thing that we're doing. And like I said, we're carrying anything that you can do on this portal, you can also do via API. So we write it, we publish the API, we document it, and we allow you to do it. And we have the same token carrying in the API side of it. But if you wanted to look at the portal experience, there's a YouTube video of that. From our point of view, right, I talked about carrying the tokens, and we carry them in both places. DOS attacks, we do worry about, certainly on the controller, et cetera. And then things in the future, what's going to happen in the future. P4 is a big one. How is that going to affect us? What are the security posture on that? The product direction itself. Product people don't always think about the security implications of things, and so we have someone on board to look at it each time we change the product. And then, who knows? Who knows what could come? It's a living, breathing platform. I've given you, didn't come out too well, but I've given you some links here if you really want to go and look and dig in. And I tried to get links that you could actually get. They're not, paid links. I think you can actually even get this IEEE Explorer one without having to be a member or anything. And they've kind of scrolled off the bottom. But some views on writing secure enforcement, the one that was most interesting for me was this one, the soft TDP. So this one actually combines the process of ISL detection and topology detection with BFD, and has some shortcuts around how you can, once you have a topology established, how you can get changes to that topology without having to do the whole LLDP type packet forwarding over again. And then this one is probably a unique paper in the space that looks at many different stateful SDN data planes. Okay, that's all I had. Thanks.
Any questions from the audience? Ready? Jeff, you might want to hold on to this.
I'm going to take this in a slightly different direction. This is Kiriti. You had this sort of throwaway line, write your own controller,
Yep.
but you have an open source controller. So, and a lot of SDN controllers are open source, like ODL or OpenKilda. So do you have any perspective on the security of open source controllers versus closed source controllers?
I think from our point of view, the things that we stuck in there, for instance, the notion of, if you write your own controller, the notion of taking that, the information packet and encrypting it and wrapping it in UDP and being able to send it as the identification packet is something you can only do you could probably get your vendor to do that if you're using a commercially based one, but you can come up with your own, or we could implement SO, whatever that was, the research paper that I talked about. You can implement different mechanisms, or you could have people, someone else wants to pick up that open source controller and write their own mechanism, right? So those are the things that you can do with an open source mechanism that you not necessarily would ever get without.
With a closed source?
With closed source, yeah.
Okay.
Yeah. Thanks.
All right, thank you very much. So on to you, Reg.
Cool. All right. So what you probably have noticed so far is that everyone that's talked has had their own view on what SDN is, and as the fourth speaker, I am also going to have a slightly different view as well. And I think that is part of the problem when we use the term SDN, because many years on, do we really have a clear definition of what it is? But so just to clarify from my perspective, when we think about the network, we have physical things, and we live in the physical world. And increasingly, we have services and applications and data living in a cloud or in NFV. And we have SDN as this way of automating all the things. So when I think of SDN, it could, the examples given before are all, to me, legitimate SDN, but they're not, they're not conforming to a single definition. What I would say is, as we shift the location of a security or management function into the cloud itself, that's not necessarily itself game-changing, but it also increases a lot of complexity, and it creates new blind spots. So moving things to the cloud is absolutely important and going to happen, but the game changes come from being able to automate and being able to manage and being able to deal with the security risks. Now, I thought, how many people actually flew in through KTM Airport on the way here? Only 2 people? Did the rest of you live in Nepal? All right. Low audience participation. So what I thought was, instead of talking about an generic SDN example, I would talk about SDN using Kathmandu Airport as the example. And really, even though it seemed like when you arrived at the airport, it was a single airport, there were 2 parallel systems. We had, if you had a visa, and about 50% of the people on my flight had a visa, they went to the 2 lines for people with visas, and the rest of us were subjected to a process that involved going to a machine and typing in your email address and taking a photo, then moving across to a fee collection desk, and then from the fee collection desk moving to the lines exclusively for people with no visas. And this is how we deploy business applications as well. We have a particular application, we set some infrastructure for it, and it runs through its own little hurdles. And then we have a different application, a second application, and we might require more firewalls these visa desks. And so we treat them as two separate applications. And the problem that we have is, at least in this particular airport, there was no DDoS protection for traffic coming in. There was only some form of perimeter on the way out of the airport. But also that the fact that we had the system operating as two different platforms meant that we had congestion on the desks for people with visas almost immediately, while a large number of desks went unused, and there was immediately congestion at the photo booths while there was no people waiting to get their fees. And so even though the traffic patterns were well understood, we still end up in a very unfortunate resource congestion scenario. And if you looked at that over some time, what you would actually see is, notice here, we only got through about 5% of the people, but now we have congestion moving across from the photo booths across to the fee desks. And there's still a large number of booths not being used. And that continues on and on. And then eventually we get a few people coming across to the no visa. And we've only got halfway through this line of people who do have a visa. I kind of feel like this stage, if they had full access to all the resources, they could have actually been completed and processed by this stage. And by the time we actually managed to get most people through the photo machines, we still have people with visas who are still waiting to get through the line, although the fee desk was the congestion point for that second group of people. And so really, even though we knew the traffic patterns, we had difficulty in reassigning resources based on the instantaneous demand. And that led to simultaneous over-provisioning and bottlenecks. Over-provisioning is bad because we're wasting resources. Bottlenecks is bad because we can't be processing at a higher volume. And there were multiple steps to process the traffic flow. Validation occurred only as a last stage. Some people didn't have their photo taken, got through several lines, then had to bounce back to the top. If this was a business application or end user experience, you wouldn't want your customers to have that experience from a network either, where traffic has to go through multiple hops only to be dropped or only to be reflected back, and then the task has to be reset and start again. And what we saw also was the egress physical security became the choke point as well. Now, this is not a criticism of Kathmandu Airport. I've been to a lot of airports. Every airport can probably be optimized. But the point is that this is exactly what we're trying to solve with SDN as well. We're trying to get to the ability to scale in and out resources elastically for any particular task. We want to be able to optimize the traffic as it's flowing across the network and embed security at each step along the way. And we also want to maintain some feature optionality. And what I mean by that is, we talk a lot about zero-touch provisioning, being able to plug something into the network and it works. But what about day 2 or day 3 or day 4 when we suddenly want to reconfigure the service models and workflows? So we don't want the workflows to be hard-coded into the infrastructure, and the way in which we enforce security shouldn't be hard-coded either. In terms of controller risks, I think this one comes up a lot. If you have a controller, or if you have a control plane or a routing engine or a supervisor tightly integrated into a system in an integrated model, then people feel kind of comfortable with that. And then it's only when you take the brain and you move it outside of the physical chassis and you use it in a distributed model, people start to say, wait a second, there's a lot of concern that we have here. The first point that I would make is that at Arista, one of the ways that we solve that problem is that when we have it embedded directly within the system, we have our operating system EOS, and we call that SysDB. When we do the same thing in a distributed model, we use EOS, and we call that NetDB. And in theory, the way in which the brain learns state from the line cards is the same whether it's for a single system in an integrated fashion or over multiple systems in a distributed fashion. And so our view of the network is full state awareness, the full topology, and all of the interfaces. And so therefore, we're not trying to infer or understand or guess what the network might actually look like because of the tight coupling there, which I think is probably one of the pros of using a vendor-based controller. The second thing is that a lot of people say, well, do you want your external controller being able to push garbage down to your distributed systems? Like, what sort of levels of protection do you want to take to make sure that the controller can't do something that adversely affects your network? Well, the truth is, if you would allow a controller in a single system to make a mistake. You have to allow a controller in a distributed system to make a mistake. So you have to understand that there's risks no matter what happens. If you send a bad CLI command or an API call to a single router, you may end up adversely affecting that router. Much like if you use it in a distributed system, if you send a bad command, you're still going to end up with a network impact. Now, the risk is that in a distributed system that the impact, the scope or the blast radius is much larger. So that's the thing that we have to consider, is the scope of the controller in both the number of devices it's managing and the visibility it has end-to-end, but also the level, the number of features that we're embedding into the controller, the number of things that we're and tasks we're asking it to do. And so we can look at those two things and see if we can partition or limit the damage that might be caused. I also want to point out, and I'm definitely not disagreeing, I completely agree with the comments earlier made, but if you notice that there's a lot of discussion around VM and VPN, and resources are much more in a virtual fashion, particularly when you look at that DevOps model of virtual resources or container-based resources, what you see is you see something like this, which is based on Red Hat OpenShift, where the developer and the operations are really looking at a platform, and then the services and applications are now hosted by a platform above that. And again, SDN really, you can consider SDN making the network a platform, and then you can have a service platform for VMs or a container-based platform higher above that. And what that means is there is a blind spot where the developers, the end users, and the operations are making sure that the services and applications are behaving correctly, but we have layers upon layers of overlays, macro segmentation, underlays using MPLS or VXLAN, and then physical networks, which become a blind spot to that DevOps community. They're not operating the physical network, they assume that it's there and working. And therefore, that becomes a security aspect that needs to be considered, but isn't inside the workflow of an individual service. And so you say, what is the scope of SecureSDN? And I don't have an answer here, but you can see that there's, potentially, a wide range of what we consider security and SDN. And I think that's part of the differences that you've seen in the presentations that preceded. If you look at how we can protect against the application layer or data plane, what I've included here is what a cloud native would do using infrastructure as code. And essentially a CI or CD process, so a development process, where you have version control and you use a base configuration. It sounds kind of overkill, but a lot of the DevOps and web services community now take their router configurations and they treat them like source code. And so when they need to make a change to configuration, they don't make that change directly onto an end device. They make that change in a version control system first. Now, depending on the way in which you build your virtual functions, again, you don't necessarily go out and change the software version on a virtual machine once it's running. You actually create a new image with the updated software, and then you deploy that. And so in that sense, we can create new automated testing and then create candidate images and then stable images based on the updates that we plan to make, and then roll them into production. And that means that there's less opportunity for a bad actor to log into a particular device and exploit it based on the lack of security patches or otherwise. And this provides version control, so you can go back to a safe version from the past, but and authenticated API calls, which provide that audit trail so you can see what's happened in the past. In terms of segmentation, this is an area where we're still kind of like in this middle ground here around micro-segmentation as being, I think a very desirable and buzzwordy kind of approach to security. I'm not saying that having virtual firewalls between different resources is wrong, but what I'm suggesting is that as we move into a container-based world or even further into a serverless compute world, it's not necessarily practical for us to consider that we're going to have a single firewall protecting an individual line of code. And if that firewall was doing that, I'm not really sure what a modern firewall would actually be looking for. You're basically saying, can they call this code function or not? And therefore, as we move into, from perimeter into macro, into micro, and into nano, into different security models, the answer starts to look less and less like just a virtual firewall. And building smaller firewalls isn't the only solution we need here. So getting close to wrapping up, I think the points that I'd like to make is if you look at the where do we start to build a secure platform? I would say that building a secure platform starts at the physical layer. And what we're seeing, particularly IXs and data hosting companies around the world, looking to MACsec. MACsec being a layer 1 encryption model that encrypts all the traffic. Started off across DCI, and now there's definitely products within the IX, or even between the spine and leaf in a data center architecture that provide full encryption of all traffic flowing over those systems. Now, the reason why that's so important, obviously, if you read any of the more recent documents about global government organizations and the way in which they can penetrate networks, essentially you can take a fiber and just bend it and then use that to intercept data coming off that fiber. So you don't even need to break a fiber now to steal the data. The second point, which I think is really, really crucial, is streaming telemetry, and including S-flow here, S-flow being a sampling of the actual traffic, which gives you the opportunity to look at the traffic, provide some form of forensic analysis. If you need to do archival and full analysis of the traffic, then a solution like a tap aggregation or a packet broking model would also be relevant here. But streaming telemetry is super important because it gives you that full view of state changes within your network. It's that feedback loop that you can use to identify when changes are occurring in your network, and you can use that to identify if things are in and out of profile. If you don't have feedback from your network, you're just telling it what to do and kind of hoping everything's working. In terms of macro segmentation, I did put down just a very quick diagram of taking a bunch of different resources across a network and then using macro segmentation to create logical partitioning. That's I think being covered as well earlier on in the goal of creating like hybrid cloud solutions. One thing that I'd say is dynamic flow control. Jeff kind of talked a lot about OpenFlow, but what he didn't talk about was some of the cool things around being able to steer traffic deliberately in a more optimal fashion once you've identified what it's doing. So here, instead of traffic going from one rack across to the firewall, getting checked, and then coming back for every single packet in a flow, once we've identified that traffic is behaving correctly, then what we can do is we can actually have a signal between the top of rack and the firewall, and they can share that intelligence, which means that in the future, traffic only needs to hairpin to the top of rack and then to the next system, optimizing the traffic flow and simplifying. So we apply all that to Kathmandu Airport. What we would actually have is a system where we had, we consolidate that second tier passport and security services for any system. And then the hope would be that while people who have a visa are very quickly processed through the line, they can be completely satisfied prior to any of the people making it through the elastic fee desks, which could scale out as more people go through the photo booths, hopefully getting all of the users through in a faster period of time, but also providing things like encryption and security for the traffic flows that happen across that network. Anyway, that's all I had, so thank you for listening.
Thanks a lot, Rich. It's a very interesting presentation there. All right, so before we open up the floor to questions, I've just got an announcement. A pair of reading glasses and a bag of pashminas was handed in to reception. So if you're missing that, please, not reception, sorry, the registration desk, please make your way there. Okay, so that was a great set of presentations, guys, and we got to see, got to hear about a few different perspectives on SDN, and I think Rich touched on a very important point, is that SDN is no one thing. So when we say secure SDN, it kind of depends on the application of SDN. So I might open up the floor for any questions that you might have. So we've got security all worked out, have we? All right, I might ask a couple. Touching on the point of disaggregation, right? It's pretty clear that we've taken, as part of SDN, no matter which iteration of SDN it is, or which version of SDN, or which application of SDN it is, we've taken formally closed interfaces and systems and opened them up. In the view of the panel, do you think that we've increased the attack surface for networks by doing that, and if so, how mature do you think our solutions to addressing that are? Who's going to go first? Jeff?
Is it working? Yeah. I think from my point of view, we've certainly opened up the attack surface. There's no doubt about it. But that's just the way things are. Customers want 3-minute provisioning, and in my platform, the danger of opening up that attack surface is outweighed by the fact that I don't have to wait 45 days for something. I can get it in 3 minutes or 5 minutes, or I can spin up a router here and spin up a router there and route a whole bunch of traffic from an event that I'm having and then shut it back down, right? If the system to do that has to be a little more pliable, it certainly will invite and attract both good actors and bad actors, right? There's no two ways about it. Are we meeting that challenge? By and large, I think we are. I mean, our system is somewhat limited. It's not as open as what, say, the original founders of OpenFlow thought, but so be it.
Yeah, in my opinion, it's both by automating. You are definitely opening an attack vector, because if something goes wrong, it really goes deeply wrong. We have seen it in other nodes in the financial industry, where we have systems acting automatically. On the other hand, it eliminates attack vectors, and the biggest attack vectors nowadays still is a human behind the computer.
Yeah, so I agree with the other opinions. I think we do increase the service, but every time you have some innovation, like a new channel, you need to look at the security also. So it's probably more work, but I think it's worth it.
So going back to what Jeff said, the time to react to any changes in the network is getting smaller, particularly as service velocity becomes almost instantaneous. And so for that reason, having something like streaming telemetry becomes a really critical aspect of being able to see what's happening in your network. If resources are spinning up and spinning down, relying on standard 15-minute SNMP pollings is just not going to cut it. You're not going to be able to see issues when they occur. Having detailed telemetry and analytics gives you the ability to look at things retrospectively and identify whether or not they were just normal network behavior or whether they're a sign of a deeper security issue.
Thank you. So, anyone else?
So let me pick up on your question. There are people who think that SDN is just a new form of an NMS or an OSS because you have the centralized control and you're doing this. So the question that you asked is, does SDN open up new threat vectors? And the way I would ask it is, does SDN open, and this is for the panel, does SDN open up threat vectors that we didn't already have in an NMS or OSS system? And to Jeff's point, imagine that you had the NMS or OSS with a portal where the customers can come in and say, I want to dial up my bandwidth, or I want to add a new security service. In the old days, you wouldn't do it with service chaining, you would do it with some other mechanism. But fundamentally, you have a more agile system, and you have a centralized control. It's just not SDN and OpenFlow, but it's a portal and an NMS. What threat vectors do you see in SDN plus OpenFlow or whatever your favorite southbound protocol is versus what you had with the NMS?
So one that I talked about was the fact that you could masquerade as an OpenFlow switch, right? So you could actually, in the protocol mechanism I described, you could get two connections if you're a bad actor to an OpenFlow network. And if, let's just say, for instance, they're running straight LLDP, OFDP, you could masquerade as a switch. You could intercept a packet that comes to you, because the controller is saying, send that packet out every port, Mr. Switch. You intercept one of those. If you have a back channel, you can then make that packet appear elsewhere. You could change that packet, send it back. You could do things that certainly in an NMS would be really hard to do. I can't imagine a system, and I've worked on a lot of backbones, where you've got a system where I can suddenly get attached to your network management system and pretend I'm a router. That's somewhere out there, right? Yeah.
But just look at how the networks work today on a layer 3. So BGP, look at how BGP works. So how easy it is to inject false information in BGP. So in that sense, I would not really say that we open up a new attack vector. I guess it's hard. I'm not that familiar with SDN, but I would say it's harder to install a ROC controller than to inject false information in BGP.
Yeah. Likely.
So, Kriti, to your point, I think, and let me just check, if you're thinking of a traditional model with network management, it's really a three-layered model. We have a data plane, a control plane, and a management plane. And so in the many views of SDN, the control plane gets disaggregated from the data plane and moves somewhere else, in a lot of ways replacing a management plane. So in that sense, and I think Jeff's examples are probably the closest to that, it does create some challenges because the data plane can't really operate if the control plane goes missing. If you look at some of the ways, and particularly the example that I talked through, you have the data plane and the control plane still physically located within each node. And then when we create a controller, the controller doesn't replace the control plane, but it becomes a part of the control plane. And so if you look at some of the protocols that we've done in the past, using things like BGP-LS to extract control plane information up into a higher layer system, that's a well understood way of the controller having the same networking view without placing any new vectors or risks on the control plane, and certainly not moving the control plane away from the devices. For best practices, I think OpenFlow or a direct flow network has some specific differences, but for standard networking, if you were looking at how your control plane moves up into a controller, so long as the control plane has a local copy and can operate somewhat independently for a few minutes if that connection disappears, then the standard network will keep on going. And at least in the example that I talked about with Arista, we don't anticipate the controller would go missing. But if it does and then comes back, then it's just a database sync. And a database sync is a wonderful thing because you can keep a track of where you were up to and then resynchronize all state changes since then. And that probably eliminates some of the concerns where with other controller systems where you would need to relearn all state again.
One point for me to add is that, as you say, telemetry and information is very important. And because now with the SDN, we have a lot more information on all the flows, we can kind of understand the patterns of traffic. And when anything is not as expected, we immediately can look at that as a security issue. And we can have actions that were already configured on the overall system to act whenever you see something that is outside the pattern of traffic that you expect. So it gives you visibility and a faster opportunity to act.
Thank you. Anyone else got anything to add or any other questions related to that? No? Well, I may ask a related question. So streaming telemetry, SFO and so on, it's great for getting data out of the network. You still have to obviously analyze all that information. So I'm just wondering, looking at all the different aspects of security in an SDN context, what would you suggest as some of the tools that operators could use in order to help them with it? Given that, obviously your first line of defense is to stop it from happening, right? And the second is, if it does happen, limit the damage to it. So in your view, I mean, what do you see as some of the tools that we can use here?
So what, to me, how that will work really is with the automation. And if we go into type of machine learning, that we provide all the data, and that it's an analysis that is done without so much if this exact event happens, then action, but also looking at the environment of patterns and understanding that you don't expect a spike of traffic between two applications, and maybe someone shouldn't be connecting to that application. Or if you see a flow that it's not as per the policy of the security policy of the company, you can stop that immediately. So you need to have the analysis linked to something like infrastructure as code that is configuring the network, so that you can stop a port on a switch or something like that immediately when you see something that you believe it's an attack.
So I had one customer, and they recently told me they saw a terabit per second of traffic between two parts of their network, so it was all internal. And now, if you were thinking about it from a DDoS protection perspective, that's something that you do more at the perimeter, so you wouldn't necessarily have the mechanisms in place to look for DDoSes within your own network. But seeing a terabit per second of traffic using their telemetry tools gave them insight into something that was happening and that was worth their attention. What they were able to do was identify it not to a security attack, but actually to a Hadoop HPC run that was about to fail. Now, the interesting thing is they actually detected it from the network, not from the application, because they'd seen all of the traffic volumes come in before the application had started to spit errors. So it's a very simple example, but it's a case of when you have the tools in place, you can very quickly see what is abnormal, and then you can start to investigate. And for anyone who operates a network, I refer to that as MTTI, mean time to innocence, which is being able to very quickly prove it's not the network's fault, it's something else, which I think a lot of us have to deal with.
Thank you. Any other? Jeff?
So I gave a talk earlier about an OpenFlow controller that we created, and one of the reasons that we did the architecture the way we did, there is a distributed bus in it, and then there is Storm technology, and Storm is essentially being able to do remote processing of events. So imagine switches sending you an event, and then you can write something in Storm that will process that event and then push it back onto that Kafka bus. That's the kind of thing that the reason that we did that is for exactly this, and other things. But we can offload some of the telemetry, we can offload, and we can detect things and write, they're called spouts and bolts in the Storm parlance, but we could write these offline routines to detect, we've seen an anomaly, there's something going on, we can process what we see out there in the network without having to bring it back all the way to the controller and say, well, now here, controller, you deal with it, because one of the most probably potent attacks is to overload that controller, right? So we're dealing with it out there in the hinterland somewhere, and we made this architecture such that you can write those things and add more and more and more of them, right? So each event might kick off a certain spout and then bolt and bolt, but that's part and parcel of that architecture. So.
Thanks a lot, Jeff. All right, so one final call for any audience questions.
It was interesting to listen to speakers, but I really missed, however, was any real-world war stories of, oh, here's a particular security incident we encountered, and this is what happened. Am I to say that we still haven't got to those yet, or could you recall, could you say a little about what really happened to you regarding attacks or some other kind of security-related incident?
Well, the first one I would say is that we have it happen all the time, is that we have customers who connect to us twice and route our discovery packets back at us, which ultimately shuts down their port immediately. Right? So they call us up and say, hey, the port's down. Well, yeah, your port's down because you've got two connections and you're routing packets back at us, right? Okay. From one of the funniest war stories I have, it involves the exchange, and you were talking about how you might block traffic at a certain point. we had, I was at another carrier, actually I was at MCI, and that's many years ago, and they don't exist anymore, so it doesn't matter, I can say their name. And we were in an exchange, and we had someone gaming us. We had someone sending us traffic, and we didn't peer with them, right? And what was happening was he was learning our routes from a third party, and then he was just sending traffic to our MAC address, right? So I had a young engineer come to me, and he says, hey, I've created this, or I've found out this situation, and here's what I want to do. I'm going to block everything except ICMP traffic to this guy. Okay. So this guy spent hours and hours trying to troubleshoot this problem because he could ping and he could trace route and he could do all these things through this network, but he couldn't actually get any real traffic through it, right? And the guy says, and I want to leave a note at the NOC, so when this guy calls, I want to talk to him. So the guy ended up having to call in and say, hey, all our traffic to you, it's dropping on the floor. We don't know what's wrong. Well, do you have a peering connection with us? Well, no, but all our traffic to you is, you know, and it was absolutely brilliant. I loved it.
So I think if you go back to my presentation, I gave four quick examples of where you could get started. They're all based on real-world practical lessons that we've learned. MAC-second encrypting traffic is a fundamental aspect. It's important that an individual user or individual application looks at encrypting their particular service chain flow, but as a network operator, having MAC-sec is about protecting you and your platform fundamentally. The second one was around telemetry, and I think I provided a real-world example of that as well. Coming back to the last two, around macro segmentation versus micro segmentation. I'll give you one example, which was we were working with a customer talking about their security needs, and they were adamant that they needed micro segmentation. And when we dug in with the customer further, it was actually their security expert who eventually said, no, we don't need this. It's not actually a business requirement. It's been added as a requirement based on, you know, essentially the CTO has decided that they want to put that in there, but without a business reason. And so we went back to them and worked through the solution to try to identify whether or not it was going to help them or not. And so that's one of the reasons I include that example is, you know, adding layers of security, adding complexity to your solution. It doesn't deliver anything in itself. You have to understand what you're trying to achieve. And finally, in terms of the controller, and I talked a little bit about having a distributed controller or an integrated model. I've had one customer in the last couple of months who's deployed our network management DevOps toolkit controller approach. And they actually required, as part of the stand-up testing, that it be switched off or disconnected, I should say, from being able to manage the network elements for an hour so they could understand what would happen in that scenario. So in those sorts of situations, it's a very interesting use case where if your controller wasn't available for 1 hour, what would happen? And that's why I think that would help us understand more robust scenarios as opposed to saying, well, that will just never happen. If we blindly think that things won't break, then that's the day we'll learn a real war story in the production.
I don't have a security incident as such to talk about on the SDN, but what I can say is that in many customers, you have the applications teams, the development teams using public cloud for some of their developments, but then not being able to take it in production because the security for the SDN is not there in place. So to really make best use of multi-cloud, you need to think ahead on how you're going to put the security policies in place so that you can really use for business.
Excellent. So we've still got a couple of minutes left. If anyone's got any burning questions still left to answer. No? All right, well, if that's the case then, please join me in thanking the expert panel here. It was a very informative session and really appreciate the time taken by all the panelists to join us here today. Thank you very much.